Yes.
All right.
Yes.
So the first thing I'm going to do, Alex, is I'm just going to show you real quickly how to make a data sheet. Okay. Not going to explain a whole lot of this. I just want you to get an idea of the flow and what a data sheet looks like and where they come from. And then I'm going to go into detail on all the elements of the data sheet and all that and explain it. But first, just to give you an idea of the flow of creating a data sheet. So what I did was I have essentially a blank data sheet, but I just, in the interest of time, I went in and filled out some of this boilerplate stuff, okay? The model, manufacturer, description, where the specifications came from, and the calibration procedure information. As Rob showed you, you can link these to a procedure in CMS, in which case if you have like documents like the actual cal procedure in a Word document or the manufacturer's manual, you can put those in there and you can view the technician can view those during the calibration. All right, so I won't spend a lot of time on that. This is pretty obvious stuff, right? Our boilerplate. But what I want to do is we're going to go and actually create the test points now. We can create test points in different ways. If it's something, you can have test points that are nothing more than a label, right? It's not actual data. It's not really a data point. It's just a label. You can also have data test points like pass, fail, that kind of thing that are non-quantitative. They're just essentially a go, no-go test point, and you'll create those manually by entering values. But the most of your test points are going to be quantitative test points. All right, and this example is going to be a pressure gauge, so all of our test points are going to be quantitative. And we build those with the test point builder. And the reason we do that is we want the specifications to be embedded in here for reasons that I'll show you as we go along. So for now, because this is a pressure gauge, I'm just going to tell we're going to do multiple test points at once. Okay, so, and this is a 250 PSI. So we're going to do 50, 100, 150, 200, 250, back down 200, 150, 150. All right, and our units of measure are going to be PSIG. Now, if you use it a lot, basically you'll know your units of measure. You can type them, but if you don't, you can come in here. Actually, I wanted the other one, just a simple lookup. Now, what's important about units of measure is it's important that you get it right because this is about the only thing in the system that's case sensitive. Of course, the difference, for instance, between millivolts and megavolts, right? Units of
Right.
measure have to be case sensitive. So the system actually has a real-time units of measure conversion system. So if your standard and your unit under test are in different units of measure, that's not a problem. As long as there's a they share a common conversion unit, then MPS can convert from one unit to the other. For instance, all of the length units, share meter as the conversion unit. All right. So there's our PSIG, our number of decimal places. We're going to have 2 decimal places. And again, I'm just kind of doing this quickly to give you the feel of it. And we can indicate what the specs are. So this is going to be 1% of full scale. And we could use any combination of these things, okay, including our, logarithmic specs for dB or custom calculators. You can do equations. So if you did have something like that, add 0.1% for every volt above 500 or something, you would do that with an equation. But in this case, we're just going to have a simple 1% of full scale. So I need to tell it my full scale is 250 and then my 1%. And of course, you could either do percent or ppm. That's selectable, but this is going to be percent. And then I'm going to tell it to create my test points. So let's insert our test points. And in here now, this function tested, this is just a label.
Okay.
So this is going to be pressure tests. And then what I wanted to do for the subsequent fields, I can either have it put in, I like to put in the pipe character, or you can have it repeat pressure test for each one, or just leave it blank. All right, and then this test number, step number, this would be like from your actual calibration procedure. Okay, this is, again, these 2 fields are utterly meaningless to MPS. They don't mean anything. So I'm just going to put 4.2.1, and that's because my calibration procedure that's step 4.2.1 of the cal procedure. All right, and then in here for my measured value, where's the measured value going to come from? Direct entry 1 value. That means that essentially we're going to enter a pressure value, or with automation scripting, if we automate it, there's going to be one value. Your other options here are mean of samples. So if we were setting up a torque wrench, we would choose mean of samples and we would set it up for 3 samples, right? Because we're going to do 3 clicks and the average of the 3 clicks is the measured value. Now, by the way, when you do that, MPS will automatically take the standard deviation of the samples and add that to the measurement uncertainty budget
Oh,
item
wow.
yeah. And then calculated prompt. So if we were doing something like a current, right, where the technicians, you're going to use something they have to calculate, like they're going to have a resistance value and a voltage value, and then we needed to calculate the current from that, we could do that. So it will prompt them to actually enter like the resistance and the voltage, and then it would calculate the current and then make that be the measured value. But for our pressure gauge, it's just going to be direct entry, one value. Now, for our reference value, the default is that for something low end like this, we're going to assume that the nominal value is the reference value. So we're going to set our pressure calibrator to output, 250 PSI, and that's going to be the reference value. If we were doing something like temperature, for instance, right, where that's
Right.
never actually the case, you set the bath to 250 degrees C, and really it's 249.95. In that case, you're going to do direct entry. And when we do this, before the technician can enter a measured value, they'll have to enter a reference value. And when they enter the reference value, MPS will automatically recompute everything around the reference value,
Mm.
including the calibration tolerance for the test point, the high and low tolerance. It'll recalculate the standards accuracies, update the uncertainty budget, and everything based on the reference value. And as Rob was starting to explain to you earlier, the as found and as left are completely independent in MOX. So you can have different reference values for as found and as left on the same
So,
test point.
so different standards, different uncertainties.
Exactly. So,
Yeah.
right, exactly. You can use different standards. And even in the case of temperature, if you did have to go back and take as left data, it's not going to be the same reference value, right? You'll set the bath to 250 again, but it's going to be somewhere else.
Right.
Okay, so again, in this case, low-end pressure gauge, we're just going to do use nominal value. Now, if we were doing high-end pressure, right, that would be a different matter, right? We'd have to get the true pressure, and that would be our reference value. But in this case, that we're going to assume the nominal is that, and we hit OK, and here are our test points, all created for us. And then it embeds in here a human-readable version of the specifications. All right, but really what happens is it's actually stored in all these test points, the actual specifications. All right, and this will become important because, as I was mentioning, when we do like that reference value thing, it has to recalculate the tolerance around that. So it needs the actual specifications to be able to do that, right? Because it could be nonlinear.
Right.
All right. So now you'll notice I've got no TARs, TERs, EMUs, PFAs, PFRs, none of that stuff. So what I need to do is I need to give it a basis for that. So that's going to be our uncertainty budget. And I could do this one of two ways. I could just go in and create uncertainty budgets manually. Okay. Or I can have MPS do it automatically. Now for that, if we go to standards here, what we're going to have is one standard, and it's going to be a pressure calibrator. All right. Now, where is that pressure calibrator going to come from? Well, in MOX, we have a thing called METSPEC. And METSPEC is a digital specification system. Okay, so you can actually store the specifications for instruments in electronic form in these METSPEC files. And these, of course, get saved in the database. In this case, for a pressure calibrator, it's relatively simple. If we go to our PSIG units, you can see these are the different modules that are in this pressure calibrator. And then so for our 0 to 45 PSIG, this is the parametric limits. This is the accuracy for 1 year accuracy. And this one actually uses a equation. So just give you a quick look at that. So here's the actual equation for that to determine that. And again, I'm just speeding through this right now. We're going to come back and look at these elements in detail, but I just want you to sort of get the flow of how a data sheet is created. All right.
Okay.
So So now that we have that, and the main usage for MetSpec really for most people are actually for using it with calibration standards. So you have the specs for the standards. Or in some cases, if you want to set it up with using uncertainties, you can do that. All right, so let's go ahead now and tell it to add an instrument to this. And we're going to import a MetSpec instrument for that. And it's going to be our CPC. And incidentally, this catalog that we're using, this is also common for data sheets. If we were building a data sheet as we're doing now, and basically, if we don't have the rights to approve it, or we're going to continue working on it tomorrow or something, we can save it as a file. And then it's the same thing for MetSpec spec sheets. If you create a spec sheet, you can save them as a file while you're working on them. And then you have to have the necessary permissions to be able to approve these into the database for actual usage. And so what you do is you save them to a file. And then when you're done, if you don't have the rights to approve them, you can just email the file to somebody that does, and they can go in and do their review and all that stuff. And if they approve it, then they can approve it into the database and it'll be ready for use. In the case of spec sheets, they'll be ready to be used with data sheets. And in the case of data sheets templates, they'll be ready to use for calibrations once they're approved into the database. And all of that is all audit logged and revision controlled. You can have multiple revisions for both spec sheets and data sheets. So if you change it, it retains the old versions. So you have all that control. All right. So here's my calibrator. And what I'm doing here is when I'm typing, it's actually looking up in the database to find that. So it's things that start with CPC. And we could search different ways, model number, description, all that. But I know the model number starts with CPC. So there's a CPC 6050. I hit OK. And then this one just has 1 year specs. So OK. This is more common in electrical stuff. You might have 90-day specs, 1 year specs. And what you would use are the ones that how yours are calibrated. Okay, so now I've got that. So now, just to give you an idea of, well, I already showed you what the spec sheet looks like, but you can also view them here in MPS as well. But now what I need to do is for those different ranges, pressure modules will be assigned to different test points, right? Based on what they are. Now, how do I do that? If I go to assign standards to the test point, I can tell it to auto assign. And what it'll do is it will use the parametric limits in there. And I'm going to tell it to do it for all test points and do the whole calibrator. Okay, so now you can see that we actually have TARs, TERS, EMUs on our risk, PFA, and PFRs computed. And if we actually now go and look at the test points, you can see that for this 47 to 52, or this 50 PSIG test point, it chose the 0 to 235 PSIG module, right? And it's actually showing me the specs for that. And my TAR is 212 to 1. Okay. Now, that's largely what you'll use spec sheets for. This is really, really super handy for like your general purpose test equipment, right? If we were doing like a primary level calibration, then, we might actually, do more with the uncertainty budget, manually, right? Which you can always do. You don't have to use MetSpec instruments. You can always just manually create budget items, and you can also do a hybrid. So you can have MPS do this stuff automatically, and then you can also go in and add other budget items if you want. Okay. But this is really the super powerful for that general purpose test equipment, right? Where you've got a ton of pressure gauges. And you don't want to have to go in and manually set up a uncertainty budget for every pressure gauge you do. This saves you a huge amount of time.
Yes.
And also you could let your technicians do this because all the metrology stuff is done in the background. So they just chose the calibrator and they basically set up their test points and they can do this. And you have a lot of confidence that basically all this is being done correctly and all of that. So, okay. So now that essentially is creating a data sheet. So what I would do is while I'm working on it, if I don't have the permissions to be able to approve it into the database, then what I would do is I would go to export the template. So I'm going to save it to a file. And then let's say you, Alex, basically do have the rights to do it. I can email this to you. And you
Oh,
can basically open the file and you can come in and review it. You can just come over here and look at the specs and say, yeah, these are these are the right specs. And then you can look at what I chose for the standards, right? Say, okay, yeah, that looks good. And then there you go. And then what you would do is you would go to File, Datasheet Template, Approve Template to Database, okay? And then you basically would approve it as a new document, or if it's an existing document, you would approve it as a revision. Okay, in which case, if there's a currently active version already, that will become inactive and the new one will become active. And all that stuff will get audit logged too. Okay, so
okay.
that's the process for creating a data sheet.